or you need the printer and somebody else has the printer. And when I say you, I mean the process. Okay? But you have these states, okay? And we're really not going to worry too much about our states per se. We're going to run threads, and we're going to have our threads talk to our clients, okay? But we're not going to really try doesn't in this first example, which is easy enough, okay? But ours really aren't going to be that way. Okay, so we have these states. Now, this is what Java sees. Okay? But the runnable state really has two things going on underneath. Okay? This. When you're in the runnable state, you're either ready or you're running. Now, what this really means to us, okay, is let's say that I start 5 processes. Okay? When I say process 1 start, process 2 start, blah, 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 they're all lined up like at the horse races, ready for the gate to come open so they can run out, okay? However, only the processor decides which process gets to go first. It makes no difference how I start them, in what order I do them, or anything. The processor gets to decide which process gets picked first. Okay? So we have an extra little state in there ready to run it before we hit runnable. Okay? That's just the way it's treated in the operating system of the job. Okay? And we're going to see this more in action in a little bit. Now, threads can have priorities from 1 to 10 in Java. 5 is your average. Okay? Or it can inherit from its parent if you extend one that already exists. Right? But to us, priorities aren't going to do a thing on our little old machine. Okay? You are the priority on the machine. Get right down to it. And it just doesn't really change much to make a priority 10 instead of a priority 6 or 7 or 4 or 3. Okay? Because you're the only person working on the machine. Now, on a real processor machine, it will make a difference. Remember also that what we're doing is really meant for multi-processors, okay, that have 10, 15, 20 processors or more. Okay? And you have more control over those because you can actually say, put this process on processor 2, put this process on processor 6. Okay? We don't really have that type of control. We just say, go run. Okay? And we let the operating system do everything else. Okay. So anyway, they have priorities. 5 is the average. 1 to 10 is they really don't do those things. This whole sleeping thing, okay? A lot of people will try to get their code to run the way they want to run by setting a priority and by trying to time out with a sleep to get the processors to run in the right order they want. Never, ever, ever do that. Never, ever depend on coding up the order of how you're going to get this to run. It won't work. Okay? And you're going to see why in just a minute when we run this example. Okay? So don't depend on coding up little tricks in your processes to try to get the answer you want. Not going to work. Okay? Now, there we go. This nifty little diagram, okay, shows you how the scheduler in the system works on processes. Now, this is one mechanism, okay. Whoever writes the operating system for your machine, they spend all their time figuring out how they're going to do it. They may do something a little different than this, okay. But this is probably the best known one. Now, here we have some threads from priority 1 to priority 10. We have 2 threads at priority 10, A and B. Now, they're the highest. So, in theory, the system looks at those and goes, well, they're the highest. They should run first. But I have 2 at the same priority. So what happens is they do a round-robin time slice. The processor will give A a little time, and then it'll move over and give B a little time. And then it'll come back over and give A the same amount of time, and then it'll come back over and give B the same amount of time. So it just goes and shares that quantum of time between the processes. It happens fast, okay? But it's really what's happening. It's not